You told me, I knew I'd screw that up. And since then, I've worked as a software engineer and INT in general. And then about sort of 5, 6 years ago, I found out, I'd heard a bit about XP and I found about Agile, and I kind of realized that I was more of a hacker than a software engineer. I'd just been hacking code about. I'm happy to admit that. Following Diana's lead this morning, I wanted to talk about some of my tribes. I'm a member of Oxford Drupal Users Group. I'm a founder member of the nearly dead Bristol Wireless, but it was a really good project for about 10 years in Bristol, doing community networking. I'm a regular attendee and presenter at Swindon Agile Practitioners, and I've got an organisation I'm involved in called Action Lab, and we do events, not quite as big as this, but around skills sharing in technology, mainly aimed at social change groups and community groups and that kind of thing. I'm also a member, that's the allotment shop of my local allotment association as well. So these are my tribes. So these are the things I've often heard myself saying over the years. Code's really awful. It takes so long to make changes. We're always introducing bugs. Who's said any of those 3 things before when doing software? Yeah. We've no idea what this bit does. Go on, keep your hands up when, right, okay, great. Bob is away, and consequently we can't work on that bit of code. We hate it. We need to rewrite it. We just need to rewrite the thing. So I've said all those things, and you lot have said it as well. So let's have a look at what it is. So here's the contentious part, I think. So legacy. In the dictionary, it's an adjective meaning that, relating or being a previous or outdated computer system, what a lot of people understand. But in software engineering, it tends to have a slightly different meaning, and that's the meaning that I'm talking about here, because I'm talking about software, not big old computers. So it says source code inherited for someone else, or source code inherited from older version of software. It's not only that, I find it source code inherited from myself. It's like my past me wanted to really screw up my future me's life. Michael Feathers, obviously in working effectively with legacy code, just sums it up as code without tests, which is kind of true, but there's more to it than that. There's more nuance about what makes the code difficult to work with, which is what I want to look at. So legacy code is a form of technical debt. Has everyone seen this thing? It's Michael Feathers' technical debt quadrant, and saying, but basically, we have stuff we do deliberately, we have stuff we do accidentally, we have stuff that we do recklessly without thinking about it, and we have stuff that we do prudently. So let's say a prudent, deliberate technical debt is something that teams do often, and if it's planned and thought about, the contractors say, actually, we're going to not do that now, but we're going to be aware that we're going to create something in the future that we're going to have to pay off, we're going to have to sort out. That's okay, but a lot of because at least you know about it, but a lot of the legacy code stuff that I've written and I've discovered is in the more reckless side of this diagram. So that's people just hacking stuff away, deliberately saying, oh, that'll do, and just not being aware that they're actually not writing the thing. So a lot of stuff I've written, it was just I was clueless. I didn't know what I was doing. There's a really long definition. An evolving program is continually changed. Its complexity reflecting deteriorating structure increases and less work is done to maintain or reduce it. Fine. Has anybody seen that definition? Bad code isn't technical debt, it's an unhedged call option. That's a kind of strange thing. So you like a call option is that a buyer agrees a contract with someone to have the right to buy something in the future at a certain price, at a certain time. And an unhedged, and so what people do is, because of that, in finance, they hedge that by saying, I'm going to take out some other kind of contract to make sure that if that goes wrong, I'm not going to lose money. And an unhedged call option is you haven't actually taken out any insurance against that deal working out badly. It's an interesting term because it's quite difficult to explain about technical debt and legacy code to business people often, and especially like accountants and stuff. And it's an interesting term, and this guy's got an article, his website's not available at the moment, but it's a good term, I think, to potentially use to explain it to people that are not software developers and don't understand it. So, to the organisation, our legacy code is a lot of investment from this organisation. It models the processes of the business, it's the history of the enterprise, it's where we are today. And it works. In general, a lot of these systems just work. There are hugely old COBOL programs written 40 years ago that just work. They're bug-free and they work. But it can be a pain to maintain and extend, as we all know. So let's have a look at some of the things that we find in legacy code, which I'm sure you've all encountered. So I'll have a show of hands for who's encountered these various different things as we go along. Oh, hang on. Unnecessary misleading comments. Poor or obtuse naming of things. Large number of calling parameters on functions, subroutines, that kind of thing. Multiple threads in single functions, so big functions that do lots of different things. Oh, no. Okay, functions with side effects. So they say they do one thing, they do something else. Long unstructured code threads, just like tons of the stuff. Poorly scoped variables, they might be globals that are used all over the place. Yeah, that's the kind of things that I say. Now, a lack of tests. How many people work on code with no tests on it? Yeah, okay. So, although I agree with Michael Feathers about not having tests make it unsafe to change the code, the actual, facets of legacy code that we encounter are all those things. They're the things that make my life as a programmer less fun than it should be. Hard work. So here's a test. Anyone know Perl? One person. Yay, one person, two people. Okay, it's a quiz. And I'm afraid, I'm sorry if you don't know Perl. So this is a function that I wrote, and it's about checking someone's login. The user accounts are stored in a database, sort of somewhere here, and the person enters a username and password, and this thing's going to check whether they're allowed to log in or not by checking here whether the username and password match the fields in the database, and over here it's going to do a thing where it's checking to see whether their password might have expired, and it does various things like sends them to an error page here if their login credentials aren't right, and here it shows the changed password page. It does continue on, but that's as much as I could fit on the screen. So, just a minute. Can anyone put your hand up if you can spot a problem with this code that makes it difficult to maintain? Anyone? Okay.
It's in Perl.
Okay. Yes, possibly. Yes. Any others?
Your description of the code just now is not evident in the code. So what you said, you can't glean unless you knew about the mechanism.
Which is why I had to explain it to you. Yeah. Anyone else? Can anyone spot any other things? So that list before? Yeah, there's a...
multiple threads, it does 15 different things.
Yep.
SQL code mixed in with your business logic.
So it's closely coupled, isn't it? Yeah. Any other ones? There's no tests. Yes. Okay, so let's have a look then, see what we spotted. These are ones I sort of found out about it. Poor naming. Okay, I might know that DBH stands for database handle, but... And query, what is it? Is that a database query? Is it a query string on a, CGI request? What's that then? Closely coupled, as you said. Whoops. Side effect, yeah, it does something else. It actually checks password expiry and redirects you to a different page. There's a misleading comment. Did you spot that one? That's got absolutely nothing to do with this piece of code at all. It's from some other thing. What else? there we go. Inelegant error handling. It just dies to the web browser. Outputting, I think, probably the SQL statement that was tried to be executed, which means that someone could work out how to do SQL injection on it. I'm passing around some global arrays into it called app options, not knowing any idea what they are or what they do. That takes a parameter, a CGI parameter, to decide which page you're going to go to. And so it's pretty much all of it, and there's no tests either. And I wrote it, so if you're thinking of hiring a software developer, then what can I say? So let's look at the causes of why I might have come to this point of writing that bit of code, apart from just being clueless. Old programming languages, Perl, but I could have written the Perl better than that. I could have written it nicer. So it doesn't mean that the Perl in itself is the problem, really. Maybe it is. Old methodologies. So we used to do kind of procedural and imperative type style programming. Now we do more object-oriented programming, or if we're really cool, we do functional programming, or what's the other one? Logical. So maybe some of the older methodologies make it hard to do things like write tests and encourage us to write very large bits of code. But I don't really buy that, actually, because I see quite often that we use new methodologies not well understood. So lots of people will basically wrap up kind of procedural code in a very large class that does tons and tons of things and say, I'm doing object-oriented programming. I certainly have.
Downstairs not talking about writing better Swift.
Yes. Yeah, that would be, yeah.
Shiny languages.
Of course, tasks done under pressure because people want to get things done. So we just kind of go in and do the fix because someone's breathing down our neck about getting something sorted. Hacks in code to solve bugs. So I've seen that a lot of the time. You know, if user ID equals 53, then multiply this random number by something done 10 years ago and no one knows why. Not knowing any better. I think that's a common thing, actually. If you don't know, if you know, like originally I went to college years ago and studied programming, and a lot of the sort of paradigms hadn't been talked about. No one had written the design patterns book, no one had written domain-driven design, no one had written clean code or any of these books. And, you know, if you just go to work and carry on like you always did, and you don't go back and kind of educate yourself on those things, how are you going to find out? Or someone comes in and says, right, I'm an agile coach, I'm going to teach you all about this. So I think a lot of things is just doing that practice, and it kind of works because you go to work and you produce code, and that's fine, isn't it? You've done your job. Knowledge silos, we said, you know, Bob's away. Only one person knows how to work on the invoicing part of the software, and so they always get that job. And there's no code reviews, there's no real peer reviews. Are any of you actually doing any of this stuff now, or are you all kind of like totally pair programming and mob programming in your agiled up, and you know, you can regurgitate like Uncle Bob's book, and who go on, admit it, anyone sort of involved in this?
A lot of we've always done it that way and it works for us, like
Yeah.
arguments, and it's like, stop checking into master, you twist.
Yeah. That's a different workshop, isn't it? The master branch thing. Yeah. How about at the back there?
In embedded systems, you sometimes still have to write C.
Yes, of course. Yeah.
I
Yeah.
inherited a big legacy code base, and sometimes
Yeah.
you've still got to get stuff done. So.
You've still got to get stuff done, that's right. Yeah. So one thing I wanted to say, in my opinion, it's language agnostic, right? So it's not necessarily the fault of the programming language. It's the fault of the way we've used the programming language in the past, often. And you can write, you know, just because you're using Go or you're writing some Node.js application, you can still write really difficult to maintain, difficult code with no tests and hard to understand. So it's not that. Whoops. So, yeah. So I want to just show you a COBOL example. Who's done COBOL programming here? Right, okay, 2 of us, right. That's more than the Perl programmers nearly, isn't it? So Okay, so I'm not expecting you to necessarily understand COBOL code, but can anyone tell me what that does and get a general feeling for it? And
Does it implement a stacking COBOL?
it does, yes. Very good.
With top pushing deep stack them?
It does. It does indeed. What I like about it is it's got quite descriptive naming on everything. The functions and variables and stuff like that. Push item onto stack. That's quite well named. Stack table with stack items in it. It's structured into different sections. It's not just one block of code. Each section's quite small. And it's got some tests. And it's test-driven. So the point about that is you can use COBOL, which everyone's written off as this old, creaky, ancient, horrible language that no one in their right mind would want to write software in, and actually write something that is clean and you can understand it. Yeah, it's procedural programming, basically. But you can do it and you can have some tests around it and make sure that code works. So does anyone feel like they want to actually now learn a bit of COBOL, having seen that? Yeah, okay, one person. My work here is done. So let's look at the effects of legacy code then on the business. These are all slides from Dr. Strangelove, by the way, which is where the title for the workshop comes from. So that's Grace Hopper, by the way, who's the person that designed COBOL. You can see there's a theme here. So how does it affect the developers? Well, we all know every time the business asks us to make a change, it takes bloody ages to make that change. And they can often be quite risky because we got no tests, we don't really quite know the code that's changing, it's quite closely coupled. And quite often we introduce bugs. So, you know, there is that, I think the figures from various reports is that 80% of the cost of software is in maintenance. You know, and a lot of that is to do with the difficulty in maintaining legacy code, and code, and also the bugs that we introduce. How many people, when they in their team on the software they work in, bugs do get introduced as a result of doing code changes? Yes, if you go on, admit it. Go on. It's just one of those things, you know. Hacking around makes things worse. The trouble is we make it worse because of the pressure, because it's difficult, because of the bugs. It just gets worse and it's horrible. And that's really frustrating. And then there's time pressure because it's like, I just wanted you to add, you know, your boss says, I just want you to add a mobile phone number field to this. And why is it going to take four months to do it or something? And that makes you hack more. And what happens is the team's got no real control over their software. So it's like, that makes the software hard to, or impossible to change. Well, if it's hard or impossible to change, it's not really software, because software should be changeable and flexible. And it's really demoralizing, actually. Well, I've always found it really demoralizing to come in and hate working on that stuff. So the business, how does it affect these guys in the board meetings? Well, you know, they want work done and it all takes much longer for them. It's difficult for them to estimate, so it's difficult for the development team, the business don't know when things are going to get delivered. The bean counters are normally up in arms because you're sort of like, well, we can't tell you how long it's going to take to do this. Because of the introduction of bugs, the customer experience goes down, trust goes down, more wasted time, more cost. I mean, you lose the customer eventually with this stuff. You get specializations in the code that cause delays. Why did I write that? Maybe someone can explain. Anyone know what I meant on that one?
I was going to mention before, when you said the silos, that we probably
thank
have
you.
it as an effect rather than a cause.
Yes, that's it. Thank you very much. Well done. How about the next? No. Yeah, it takes longer because there's only two people that know how to work on it, or one person, and then it's risky because if someone leaves, if Bob goes, what's going to happen when Bob leaves? You know, tears. And that's the danger as well, because you get those not only with knowledge silos, you get people with power over that knowledge silo. You know, it's like only this person knows about this, so we have to look after this person because it's a risk. So that person can start behaving however they want and you can't challenge them. So that's a big risk, both for the team and for the business. Has anyone worked with anyone like that? Okay. That's good though, not many of us, you know. So what can we do about it? Right. We can stop writing it, can't we? That's it. So we just all stop writing it. But what can we really do about it? Because that's easier said than done. Now, most of you probably know this stuff, but let's see where we get with it. So, okay, I have thought about doing that. I did manage a team, and I just kind of wanted to fire the bastards and get a new team. But the problem was, I was the problem with that. You know, that's not the right attitude. What we needed to do was change as a team. Okay. You can just leave the job and go and work somewhere else where they aren't writing legacy code. I mean, I'm not sure who isn't, but, you know, that's an option. If you're really upset and frustrated with the team you're working in, maybe go and find another job where maybe the company's got a different attitude. They're really into Agile and Lean and XP, and they're willing to invest in it and support people sorting out the legacy code. You know, it is an option. Right, now, so this happens quite a lot, doesn't it? Who's been in a project where that's been the... Can you read that? Sorry, people at the back. Right. So it says, throw everything we've done away and start again using something cool to do it in. Who's done that? Who's been on that project? Right, okay, a lot of us. I've been on that project. So let's have a look at this option. This is my most exciting slide. The total rewrite. Okay, so it kind of goes like this for me in my experience, so other contributions. So we're going to put a team together. They're going to rewrite all the code, and we're going to do it in some cool thing. It's going to be microservices, it's going to be cloud-based, and it's going to be really exciting and modern, and we'll use whatever the trendiest programming language we can find now to do it in. But we've got to keep the old system going whilst we do the new system, of course, which means adding changes to the old system probably, because it might take a long time. And the spec often from the business's point of view is that the new system's got to do what the old system does, because that is the spec. You know, normally the old system's been around a lot. It's kind of core to the business's processes. It's got a lot of value for the business, and it's just got to do what you know, the same thing. Is that the kind of plan normally that everyone's been involved in? So let's have a look at the pitfalls of this. It costs the business money to seemingly stand still, because initially you've got to go and deliver this thing. We've got to make changes to both systems. Do you know the Zeno's paradox, or the one about Hercules and the tortoise? Do you know that? Who knows that?
You've got to get halfway and then halfway of the remaining distance.
Exactly. So the idea is, it was Zeno came up with this, he was a Greek guy, and he came up with this thing that there's a tortoise and a Hercules, and they're having a race, and the tortoise gets, say, a 100-meter head start on Hercules, and they set off. So by the time that Hercules has got to the place where the tortoise started, the tortoise has moved ahead. And then, so by the time Hercules gets to where the tortoise moved ahead to, it's moved ahead again, and it keeps moving ahead. So it's that, you know, moving goalpost. I don't think, incidentally, he said that like in sort of 3000 BC or something, and no one's actually managed to completely disprove that paradox.
Where integration in mathematics came from, and it took them a few thousand years to actually work out how you solve Zeno's paradox.
There you go. There's the other one about the arrow, isn't there, as well? But yeah, so have a look at that. So basically, you know, you're trying to do a new system, replace the old system, and of course, there are new features being added all the time. So presumably everyone that's been involved in that rewrite project has been there as well, where the legacy team is adding features to the old system that the new team, because they're writing some other part of it, haven't got time to write that feature yet. They're going to do it in the future. Do you re-implement all the bugs in the old system? And the other thing is, whilst you're doing this, the old legacy code doesn't improve because you're sort of neglecting it. You've decided that we're going to stick it in a box and put it in the corner and leave it there and hopefully chuck it out once we've got something new and shiny to replace it. You could run into delivery pressures with it. which means that if you get too much pressure, you could end up putting more legacy stuff in the new system if you're not careful. You're going to run 2 teams to do this? And what if you never make it, which is really like the old legacy code doesn't improve? Has anybody been on a project where they were going to write a new system, replace an old system, and it never happened?
Failed.
It
Yeah.
totally failed.
Yeah.
So then you end up with a bit of a new system and the old system
No,
still,
they just scratched the...
and went back to the old system. And had the old system improved,
No, it was still fucked.
it was still fucked, right? And so where would they? They just spent loads of money and time
Yeah, totally.
and had the same old stuff. Had a,
Yeah, we ended up with in fact, we have the old system embedded in the new system.
well, yeah, okay.
We have both problems.
So what can we really do to do this? And I think this is my sort of crux of it. We can change our attitude towards the legacy code, which I think is the important thing to do. So we can stop hating it. It might be difficult, but we just have to stop hating it. And we can stop blaming others or ourselves for writing it. Because, you know, I've done that a lot in the past, in the bad old days. You know, I say, no, God, whoever wrote this code was an idiot. Like, why did they write this? And then it's like, oh, I did. Okay, what was I thinking? You know, it's not useful. That's just not useful, is it? We've got to accept it's what we've got and where we are and stop sort of denying this thing and wishing it would just sort of go away. So you can't run from it. You can't ignore it. There's nowhere to hide. And we have to believe that we can make it better. So if we believe to make that legacy system better, we could have made it better and been in a much better place than believing we had to run away from it and replace it with something else. So man up and deal with it, or woman up. Yeah, there's not a gender neutral. But toughen up, thank you. Toughen up. Toughen up and deal with it and make it better. So what can we do to do that? We can improve our tool set so we can get like the best IDE we can get for the language that we're having to maintain, and we can get other tools like linters and that sort of thing, and cyclic complexity checkers to kind of help us analyze our code and look at where the problems are in it. We can adopt within our team code standards, styles, patterns, approaches, just different ways that we agree that we're going to use to be consistent with how we do it. Doesn't necessarily matter what they are, but we can refactor the code to make life easier. And we can learn techniques to do that. There's techniques, there's a workshop here at 3:15 that's going to be about that, how to do it. I think pair and mob programming, certainly pair programming. Who does pair programming? Cool. Who does mob programming? A few less. I certainly think pair programming is a good way to sort anything out. And I think it's certainly a good way to sort out the legacy code issue and refactoring issue. Two heads are better than one. We can do things like apply solid and clean code principles. Anyone tell me what solid stands for? Okay, we'll move on from that. Yeah, go on then.
Oh, single responsibility.
Yeah.
Open for extension, closed for modification.
Open close principle.
Yeah.
Open closed principle. Liptrosh substitution principle. Interface segregation principle. And
Inversion. Well done. Brilliant. We won't go into what any of those mean right now, but especially Liskov. Find themes to replace and improve parts of it. So find bits of the old code that you can do. Find ways of hooking into it. We'll have a look at that in a second. Use TDD. So you can put tests around code, even procedural code. Who's read Working Effectively with Legacy Code? I know it's quite an old book now. Yeah, read that. It's quite useful. It's a good way to look at how you might be able to put tests around things. And sort out bad tests. Bad tests are worse than no tests in my book. I mean, I've been faced with tests that actually didn't test the code, and so you'd make a change, run the test, and go, oh, it passed, brilliant. Deploy bug, because that's worse. It would be better if there was no test, because at least I know what the risk is. So if you encounter bad tests, delete them and write a better test for it. but delete them actually, I'd say. So quick one on seam slices and stranglers. So introduce seams. You know, who knows what seams are? Okay, so you can take bits of the code and find points where you can interact with it, where you have a way of changing it or interfacing with it, like putting a test around it. Again, working effectively with legacy code explains those. You can extend the legacy code by wrapping it to extend the functionality of it. So take where it is, sandbox it, put something around it, which sounds like what you guys did with the old system in the new system. You can create slices of new functionality to go alongside your legacy system. So you can accept that the legacy system will stay, and you can just write that bit of new functionality, new architecture, in your trendy microservices thing as well. So you can abstract resources. So where you've got closely coupled code and stuff like that, where you've got like a monolithic thing with the database tightly tied in, then pull the database out into its own place, you know, create a layer of abstraction for it. Strangler pattern. Has anyone heard about that? It's worth looking at. The idea is that's a tree, that's ivy going around a tree, and what ivy does is it uses the tree to support itself, and eventually it kind of kills the tree, and the ivy's left. And the idea of Martin Fowler's strangler pattern is that you start to build something around the legacy code that eventually sort of squeezes it to nothing, and it disappears, and there's nothing left. So it's worth reading about that stuff. So refactoring, we're going to have a quick look at that, and then hopefully finish. So you should be refactoring continuously in development. So you should be doing the red-green refactor cycle. So write a piece of code, whether it's new or old code. You've got your test, hopefully, run your test, improve it. You shouldn't have to wait for the Scrum team or whatever to decide that there's a story on the board to tell you to refactor. It kind of should be part, as a programmer, what you do. You write code, you refactor code, you test code, you write more, you refactor. That's the same thing really. It's like once you've written that new thing that does what you need to do, go back and see if you can improve it, see if you can make it more succinct and everything. Yeah, get rid of that stuff. I mean, it's really not much use. Comments, if you're going to have comments, who puts comments in code? Okay. Okay. Who wants to say why they put comments in code? Right, okay. But why would you put a comment in a code?
Only to explain a particular, if there's a really, 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 really good reason, and usually the only one is if you've made a decision one way or the other on how to implement something.
Yeah, okay, that's a good reason.
Usually, if a business decision has been made to change functionality from one thing to the other,
Okay.
I put a comment in with a link to the issue tracker
Okay.
to explain this is actually how it should be. It looks ridiculous, but just go with it.
Okay. But you could put that in the commit message, I presume, if you're using version control.
Someone reads the code
And they don't know.
understand it.
Okay. Yeah, so I think whys are all right. Whys are the only reason. There's a business reason. There's an actual bug in this library you're using, and there's a Stack Overflow article that explains it, and here's a link to it, and that's why it's like that. But the whats and the hows, those old users comments that says, I is an incrementer for such and such. Just call I something decent, and then you don't have to tell people about it. Yeah, do that renaming so that they're more self-documenting. Break up lengthy code. Often very long procedures are a candidate for classes, you'll find, if you've got procedural code. Who works with procedural code? More, not, yeah, a few of you. So that's a candidate for a class. Encapsulate common code and data into classes, yeah. Abstract resources from the main code and decouple. Already said that, really, didn't I? So let's, if you can't write any tests, try harder. Write some tests, yeah. So let's have a look at that code again and see what we could do with it. Okay, well, it's a web application for a start, I know that. So we could write some high-level tests in Gherkin, for example, just to make sure that whatever I'm going to do to change, because sometimes with procedural code, it's quite hard to put unit tests around that at the moment. So if I take a high level, that's going to give me what the thing's supposed to do. I can look at the existing functionality, write this test, and make sure that whatever changes I make, it still works. That's my contract. So I can start doing things like extracting the domain functionality, like, for example, a user from there into a class. And yes, you can do object-oriented programming in Perl. In a kind of funny, weird way that's hard to read, but yeah. I could create a database class to abstract my database away, and I can write some tests as well. So it's brilliant. So I've got all that thing, and then I can kind of basically take that and make it a bit more readable. Yeah, I could improve that a lot more. I could probably carry on, but I might get to that point and think, well, I've actually done enough, because if you read that, it's nice and short. I can actually fit it completely on the screen, because the first bit's only down to there. And it makes sense, and I understand it. And I've got tests around most of that now. So 2 refactoring actions to take if you're interested in doing more about refactoring is go to Kevin and Adrian's session, which is in here at 3:15. So do that. I'll be going. Where's that other? Oh, yeah, there you go. And that's a really good video where Woody Zool and Llewellyn Falco do some refactoring live. It's worth a watch. What the business can do to help all of this? So we're all mainly developers here, so it's a bit hard, because I'd like to say, business people, this is what you can do to help us sort this problem out. They can understand that it will take time for us to sort it out. They can provide support and training and coaching for us. Well, support training and coaching. Maybe they're not going to coach us themselves. They can create a safe environment where it's all right to question that. Does this sound like your boss, anyone? Put your hand up if it sounds like your... Yeah, okay, one person, lucky man. Okay. They can take pressures off the team a little bit and understand that if it's going to take time to sort it out, we've got to stop putting the pressure on. And you can appreciate that is, you know, I've encountered a problem where people are resistant to change. They've always been doing it that way, and so they're happy. You know, they're delivering software, and they don't want to change, really, and that is a difficult thing. People learn in different ways as well. Like, not everyone can read a book. I think that's where pairing works much better, pairing and mobbing, because it's the whole team sharing knowledge together. People will learn at different speeds as well. You know, young guys that are software engineers that are 25, that haven't got anything to do in the evening, can read lots of books and do a lot of coding, but someone with a family who's like 45 maybe doesn't want to do that. So you have to appreciate that in a team. And some people just will not want to change. What can you say? Okay. So this is how I learned anyway, hopefully. I realised that it's an asset to the business. I realised that it needs caring for, and we can improve it. Not to blame myself or other people. That I had to own it, that we all have to own it and say it's our code, that we can have pride about it, and that we could and had to make this code better, otherwise it will be around for years as like some monster in the cupboard. And I think the big rewrite, although it's tempting, it's quite a risky thing. And every time I hear it all the time, people saying, I'm on this project, we're going to rewrite this system, and it's scary. And getting the right tools and applying the right practices, all the stuff that a lot of you know about Agile and XP and Lean and everything that we're talking about at this conference, applying them correctly and using them are the things that are going to help us through this. It's like a therapy session, this, isn't it? I mean, some books. If you've not read any of these, I'd recommend them. Working Effectively, Legacy Code, Clean Code by Bob Martin. The Clean Coder, which is really good. Who's read The Clean Coder? Yeah, it's a great book, because although Clean Code's about sorting your code out, the Clean Code is about sorting yourself out. And when I actually read it, I thought, yeah, no, actually, I am a software professional. I am a crafts person. You know, there is a craft here, and I should have pride in that. And it's a really good book. That's quite a new book. That's really interesting. It's got a great bit at the beginning. Who's read that at all? Anyone seen that book? The first bit, which is about 80 pages or something, is all about the state of the software industry. And it just sort of goes through it. And it's really worth reading, I think, to just get a feeling for where we are. And the second half is about practices that you all know, like TDD and pairing and stuff. Lean Software Development. Who's read that? It's a good book, worth reading. It's the sort of thing that a whole team could read as well. One of the things we've been doing where I work and where I last work is book club. So we pick a book and then we read it together. It's like a sort of late night Channel 4 type thing or something here on Radio 4. So what we'll do is we'll read a chapter a week or something and then spend half an hour discussing that chapter. That's a good thing. That's a good book to read, you know, cross a development team with a BA and a PO and stuff, because it's not at a technical level, so it's worth reading, I think. Refactoring, Improving Design, Martin Fowler's book, which is there's a new version coming out in 2018. And Head First Design Patterns is a good way to get into design patterns, because the original book, although good, is kind of boring, and that's got lots of pictures in. Domain-driven design. Oh, and that's it. And that is a bit of COBOL to finish off, and that's it. Thank you very much.